Hi there. For my last video I wanted to measure the capacity of a 9V nickel metal hydride battery when discharged with fairly low currents. You may have wondered why not using a USB tester like the UM34 or the slightly older UNI-T 658 for this job instead of the fairly complex method I used in that video, which involved capturing battery voltage at regular intervals, collecting it in a spreadsheet and then do some calculations to get the capacity. After all, USB testers have a built-in function to display capacity directly, and most can handle more than 5 volts. Well, there's a good reason for this and something you may not be aware of, so let's dive right into it. To demonstrate the problem, I have set up a fully charged 9V battery and connected it to a 440 ohm load resistor through the UM34. The battery and resistor are the same from the previous video, so we know that this battery should sustain this load of an average of 20 milliamps for slightly more than 10 hours, resulting in a capacity of slightly above 200 milliamp hours. The UM34 comes to life and displays the voltage, which is slowly decreasing, and the current of 21 milliamps, which is correct for a fresh battery. The capacity and energy readouts are also increasing, although the dark red capacity readout is hard to read as the display is at its lowest brightness setting. After just 6 hours and 2 minutes, we have already reached 7 volts, which means the battery is empty. The displayed capacity on the UM34 with 114 milliamp hours is just over half of the correct value of 210 or so milliamp hours. Since it's unlikely that the battery has gone that bad over just a few days, it appears that the load must have been far greater than the current displayed on the UM34. To show the problem better, I recharged the battery and repeated the setup, but with one change. There is now a multimeter between the battery and the UM34 to display the current drawn from the battery directly. Connecting the battery, and there's your problem, as the Mythbusters would say. We are drawing more than 35 milliamps from the battery, but the UM34 only tells us 19 to 20. The excess current is in fact used to power the UM34. This is easily demonstrated if I unplug the load. Now the UM34 shows zero current, but we are still drawing 15.6 milliamps from the battery. Let's see how low we can get. I turn the display off with still no load connected, and we are just below 10 milliamps. Reconnecting the load and turning the display again off drops the combined current to just below 30 milliamps. You may conclude that you would simply adjust the load resistor to accommodate for those extra 9 point something milliamps, and in principle that is indeed so, but it turns out that the UM34's consumption isn't all that constant, and if you count on having the display off, it may unexpectedly come back to life when the UM34 detects a sufficient change, as you have just seen, but what constitutes a sufficient change is not defined as far as I know. So far so bad, but what about another tester, like the UNI-T UT658 for example? I'm afraid it gets worse. This is the same setup, just using the UNI-T tester in place of the UM34. We are drawing 26.44 milliamps from the battery, and the UNI-T tester reports this as zero. In fact, currents below 45 to 50 milliamps are always shown as zero on this tester, as I have previously explained in my review of the UNI-T tester. If I unplug the load again, we can see that the draw of the tester itself is just below 7 milliamps, which is less than the UM34, but you can still completely discharge the battery with it, and the UNI-T tester will not register a single milliamp hour unit. Of course, it is debatable if showing consistently zero is actually better than showing a wrong number like the UM34. What about charging, you may ask? This is the setup. On the left, we have a power supply that provides a source of charge current, and the blue multimeter measures this current going into the USB tester. On the other side of the tester, we have the battery connected through the red multimeter, showing the current going into the battery. Please note that in this configuration, because the positive lead of the meter is connected to the positive battery terminal, it will show current flowing into the battery as negative. Without the battery connected, the blue meter shows just the current drawn by the UM34 itself. The red meter shows of course 0, and so does the UM34. When the battery is connected, the charge current of about 20 milliamps is shown negatively as explained on the red meter, and the value matches the UM34. The blue meter shows the sum of the battery charge current and the current consumed by the UM34. So because the extra current comes from the power supply, in the charge scenario the UM34 will display the capacity correctly. But hold on, watch this. If I disconnect the lead to the blue multimeter, I'm basically turning the power supply off, but the UM34 stays on. Why? Because it switched internally to get its power from the output instead. It displays 0 current, but as the red multimeter shows, the current direction has reversed and we are now actually discharging the battery with 15.6 milliamps. If I plug the lead back in, everything reverts back and we are again charging the battery. This means the only time you can use the UM34 to monitor charging is if the charger never stops. If you try to measure a more modern quick charger that pulses the battery, you will get wrong values because the UM34 sneakily discharges the battery in the process. What about the UNI-T tester in charge mode? This is the same setup, just replacing the UM34 with the UNI-T UT658. Without the battery connected, the tester draws just below 7 milliamps from the power supply. With the battery, the red meter shows about minus 20 milliamps, which is the charge going into the battery, and the blue meter shows the expected sum of charge current and the current consumed by the tester. The UT658 display shows still 0, so in this setup we can charge the battery for days and the tester will not register any capacity. And what about disconnecting the power source? Yes, it's the same behavior. The tester stays on and switches to draw its operating current from the output, so we are now discharging the battery. The UT658 displays doesn't show it, of course. This chart paints a rather bleak picture. It shows the error in percent introduced by the non-accounting of the power consumption of the tester when discharging or load testing. The blue curve represents the UNI-T UT658, the others the UM34 with different settings, red being the lowest, no display and no Bluetooth. The yellow is the setting I've used in this video with a display on the lowest brightness and no Bluetooth, and the green curve is max brightness and Bluetooth, which should actually be 27 instead of 25, but you don't want to use that setting anyway. The blue curve is unique because of the UNI-T's behavior to display anything below 50 milliamps as 0 and ignore it. I don't think the fact that they only start measuring when the error drops below 10% is a coincidence. At least they thought about it. The UM34 on the other hand has no scruples to present numbers with errors as high as 70%. Take the case we did earlier. For 20 milliamp discharge, the yellow curve indicates a theoretical error of staggering 43%, and indeed we measured only 114 milliamp hours when in fact that should have been around 210 milliamp hours. I tried this off camera with a larger battery that could handle the 200 milliamp load displayed by the UM34. It measures a capacity of 424 milliamp hours when the true capacity was 462, an error of around 8%. Of course, since the consumption stays the same, The higher the current flow through the tester, the less it matters proportionally. Yet, although I'm aware of these principles, I kind of forgot how large that error really is. Let's be clear, any USB tester has to be powered from somewhere, and since they are all built similar to this, the power needed for processor and display is tapped off before going through the shunt resistor to be measured. So the source end is loaded with more current than what is reaching the load end and what is showing on the display. They could in principle reverse the sense and VCC connections in this schematic, and the effect would be that we would always see the processor consumption on the display, but then we would surely complain that display reads always too high, that is, showing more current than what is actually going out to the load. So you just can't get it right, no matter what you do. What are the effects on accuracy? Voltage is generally okay on either side because the drop of the shunt resistor is very small, and by the time the current gets high enough to make this matter, the effect will be swamped by the far higher drops in the USB connectors and cables on both sides. Current from source is a problem. As we have seen, it pretty much rules USB testers out for precision source current measurements. But if you're only interested in ballpark figures, it is usable. As a rule of thumb, at 50% for currents below 50 milliamps and for more than 1 amp, you can pretty much ignore the error. For precise measuring current to load, on the other hand, USB testers are fine. Current from load happens if the source is suddenly turned off and the tester starts drawing power from the load. You want to avoid that situation. Measuring source capacity, milliamp hours or energy in milliwatt hours, is fundamentally flawed because it uses the current from source, but it has the additional problem that the error accumulates over time, so even relatively large currents will cause noticeable errors in the capacity measurements. On the other hand, capacity measurements of a load is generally okay, but in case of batteries as a load, ensure that the power source remains always on, otherwise the tester will draw power from the load which discharges the battery without accounting for it in the current or capacity measurements. Let's go back to the original problem of measuring the capacity of a rechargeable battery. As we have seen, if the discharge current is low, USB testers are completely unusable for this purpose. Even for higher currents, the error accumulates and the displayed results are too low by some margin. Using USB testers to measure the charge going into a battery is fine, even for low currents, except of course for the UNI-T, which insists that the current be larger than 50 milliamps before showing anything. The only issue can be caused by chargers doing pulse charging, because not only do these testers not account for the power reversal in their capacity or current display, but they also start discharging the battery. There's a similar issue if the charger turns off after it detects that the battery is full. If you do this unattended, your USB tester will now draw power from the battery, possibly for many hours. So in all, USB testers have their place, but one needs to be aware of their shortcomings, of which there are quite a number of. Thanks for watching.